The idea today is to start from scratch. We are going to use R as a language and R Studio as the IDE to code. So that's probably how you are going to work always. It's hard that you open R. So probably you are going to open R Studio, some other IDE, and code there. You are not going to see R and as the main tool to work, but it's going to be there for us to do a lot of things. Why are we telling you that perhaps some coding is going to be good if you are already knowing pretty well how to use spreadsheet? In what moment you want to make that jump to say, okay, until here, spreadsheet, Excel, Google Sheet were amazing, but now I need something else. Well, spreadsheets are pretty good for data entry, for do some quick charts to see the raw data, to filter, to coloring, to see how this information is, but has some things that can be problems or not, that you can make mistakes when you get data into, you can perhaps change the data. You don't have a specific limit between what is data and what is an analysis. And I don't know, you tell me in the chat if this happens to you sometimes, but when you have a complex analysis on a complex spreadsheet and you open that spreadsheet, for example, Pao made an spreadsheet I have to open and understand, that can be hard sometimes. And sometimes it's not only Pao, it's Shani from 1 year ago. Sometimes I open my own spreadsheet and I have a hard time to understand what I was doing there. That's only happens to me or my friends, or that perhaps happens to you. Tell me in the chat. Are you familiar with that feelings? To say, oh my God, what is this formula? Why I have so many sheets here? Yes or no? I see some smile. No one wants to say me, but I know that I'm here with some other people feeling the same. Okay, I see some yes there. Okay, there is when the coding of the programming language come to the scene. With the programming languages, we can write step by step, like a recipe about what we want to do. Yeah, some things I need to read this data, I need to plot this data in this way, I need to transform this information. If you have some analysis that you are going to repeat, that you have to do the same kind of process to your data, programming languages are a pretty good tools, because once you write, then you run this every single time you need, and you only need to change the data that you read, in case that what is changed is the data, for example. Or you can only change some parameters. For example, I work with weather data. So every single month, we did exactly the same report about temperatures and rain and other variables that are in interest of the agricultural sector. So we only need to change the month. And if I do that in a spreadsheet, I have to change the data, I have to copy and paste the plot on the Word or the PPT, and then I have to transform to a PDF. With coding, we can do all that once, and then we just change the months and run the report every single month without change anything else. So if you have that kind of work, of task, it's pretty good to go to a coding language. The other thing is that when you open that program 1 year later that you write, if you comment good enough about what you were doing, it's not going to take you so long to understand. And you can also share this with other people, because, you know, computers are dumb. It's a dumb box. So you have to write every single step that you need the computer to do. So that is a step-by-step explanation of how you process, how your analysis is going to be. Are you agree with these things that I'm saying? Are you feel that it is, well, this has sense? Or are you saying, okay, I see some, okay, awesome, thank you so much. Okay, the idea is that we try to work together. So I'm going to share with you an RStudio Cloud project that you can open in case that you don't have an RStudio in your computers. And if you can, the idea is that you watch what Pau and I were going to do on the screen, and you try to replicate these steps. So if you have only one screen, we recommend you to split the screen, half for you for your Studio Cloud project, and the other half for the Zoom. It can be in the vertical or the horizontal way. So perhaps, I don't know how the size of your screen are. If you have two screens, one for the Zoom and the other for the RStudio Cloud project. Pau already shared on the chat the link to the RStudio Cloud project, and I'm going to share my screen now so we can go together through this. I'm going to move you, so I'm still watching you to this side. So right now, when I look for my side, I'm watching you. I'm not watching the windows or something like that. Yeah? I'm watching you. And I feel like a plane pilot with all these headphones and all these things. So are you seeing my screen? Can you do some thumb ups? Awesome. Okay, this is what appears when you go to the link. And if you already have the account, you can log in. So I'm going to log in with my Google account. I have many Google accounts. And you are going to see something like this. This is loading the project with all the data we are going to work. Okay, awesome. Bernadette, tell me she's in. Okay, you should see something like this. This is the RStudio IDE. You are going, are you hearing my kids laughing? They're playing, so we are going to listen perhaps. Okay, when you get into RStudio for the first time, you are going to see something like this. The RStudio on the computer doesn't have this URL here, but the rest of the look, it is the same. You are going to have the console here, where we can write code, the environment here. Here we are going to have all the objects, variables, and things we are going to be creating when we coding. And then several panels that have files. For example, we have some report here, some data, plots, package, helps. This is a very important tab. And the viewer that sometimes show us some outcome from our code. Okay.
Sorry, don't know what happened there.
I'm saying too much things that don't have sense. You tell me. Someone stop recording. Pau, you.
Your voice got cut. That's it. You were saying the right things. Don't worry.
Thank you, my friend. Okay, so we are going to learn about these tools that RStudio IDE give to us during the workshop. So the first things that we are going to do is to see how we can write something. I'm writing down on my left, right? Izquierda? Yeah, left. Yes. And you see, I did 2 plus 2. And if I hit enter, R answer me with the result. We can do this with every single code that we want to use. R is going to answer us immediately. This is a kind of different for another languages. For example, Python, when you have to write, compile, and then you execute. This is an interpreter language. That word is hard, but I hope you understand me. That means that R is going to answer us for every single line of code we execute, we give to them. And the other thing that we can do is to save these results on our code in things that we call variables. So I'm going to put X. I'm going to write this arrow. That is the assignment operator. And it is the same that to write X equal. And then what we want to save on that variable that we name X. So I'm going to use the 2 plus 2. I'm going to hit enter. And right now, R show me the symbol of the prompt. Don't show me the 4. So where is the X? Where is the 4? If you watch up right in the environment panel, now we have an X that is a variable that has the 4 inside the variable. People who are already coding know these things, but the concept of variable in the memory is very important because we are going to save some steps of some result of our process in this kind of object. And the variables can be a number, can be a full data frame, can be a plot, can be a table, can be a lot of things. So I can save here almost whatever we produce with the code. Any questions? You can write on the chat, and you can use the hands. All good, thumbs up. Awesome, I see. Okay, thank you so much. Okay. This using R in this way is pretty useful when we are trying things, when we want to see what this code does, how is the result, but most of the time we are going to use R scripts or R Markdown. So the idea today is introduce you to R Markdown. You have on this project on the right down on the Files tab, a file that's called Penguins Report. So I'm going to invite you to click over there. And right now we have one more panel that just opened with the file, and the console was on the bottom. I'm going to minimize the console so we have more screen to see this file. And R Markdown is one of the beautiful things that have R and other languages. We call these notebooks. And the nice things about this is that you can have text that explain what you are doing, mixing with code. So this way you can process here, make the tables, make calculation, make plots, and you have also there the text that explain the results. So you don't have to process this in the spreadsheet and then copy and paste to Word, for example. It's going to be all here in the same file. And that is pretty interesting because the explanation of what you are doing is along with your code. And that is pretty good, especially for your future self. In 6 months, 9 months, when you have to go back to this after other analysis, a paper, some grants that you have to fill, you are going to open this and you are going to be really grateful with yourself because you write and explain the ideas behind that code and what it's doing. So an Markdown, it is a plain text file, but have some special syntax. We are going to see text in green, in blue, and black. We are going to see what that means. And we are going to have some white and some gray parts of the document. The white part are text that has Markdown text that have some syntax that we should know. For example, these two hashtags, you call this hashtag? This is a subtitle. If we have 3 hashtags, it's a subtitle of another level, 4, 5, whatever we want to add. So the font is going to be more hashtags, more small the font, perhaps it's going to be bold or not. Then we have these 2, I don't know how you call that, asterisco, star. Yes, okay. So two of these is going to be bold, and one of these is going to be italic, for example. Then you have this syntax for made links, square brackets, and the other kind of brackets with the link. I need to learn how to name the symbols, I'm sorry. And then along with the text, you have code. These are chunk codes. While we have here some R code, and we are going to, during the workshop, we are going to see what this does and how we can read and modify this. So here we have another more text, and then more code, and more text, and more code. And what we do with an Markdown file is knit that document. I don't know why it's the name, but it's pretty funny actually. So I invite you to knit the document to
Because
see.
you need code and text all together. You
That's
intertwine
nice.
your code and your text.
I like that idea. Okay, I'm not a neat person, so. Do you see the second screen that's open with the output? Do you can knit the report in case you are following and you're trying? Okay, this is how we see what is right in that Markdown. So you have here an explanation of the data. Here is the bold font. Here is the link that I show you. And here's what the code does. Here's a table. Here's 2 plots and more text. So if we see this next to the code, okay, let me see where he goes. Here is. Check this title here. It is this about the data here. Here is this text. And what you see here, it is this table that we have here. So this is one of the most powerful tools that we are going to have to be able to do reports and to try to automatize our tasks. And it's something that is pretty useful to reproducibility because we can share, just like we share with you this project, you can share this with people you work on your team, and they can see exactly what you see, and they can knit and get the same things that you have on your computer. So that is pretty powerful for research and for collaborate with other people. So I'm going to invite you to watch that Markdown that you have opened there. And if you can find on the code the mention to Chen2, which is one of the species of penguins we are going to use during the workshop. I lost the chat. Here is, because I don't know how to pronounce that cool. But we are going to give to you some minutes so you can go through the text and try to find this, where the species is mentioned. Check one quick tip. If you highlight, select the word, RStudio highlight that word in other part of the document. So check this out and try to remember where you see this, because we are going to do something after. I'm going to shut up so I'll let you found the words. And you can tell us on the chat if you found, or how many times you found the word. Okay, awesome. 7 including the tiles. I believe 4 times in the text. Great. Someone can tell me this word appears in the R chunks, in the code chunks? Three times in code sections. Thank you. 3 times. And in the name of the data set. Okay. Awesome. Thank you so much. One of the things we are going to try to do today is to think if we want to do this report for different species of penguins, then we need to change this on the text on the report. And doing this by hand can make us to make mistake. Perhaps we forget to change this at some place. Perhaps in some place is we need it all in one capital letter and then the other not in a capital letter. And so it's not that always we are going to do a find or replace so easy. So we are going to try to use parameters so we can change one time and change in the entire report. So we are going to try to do this today. Okay, one more thing before we go to the other topics about the armor dam. I'm going to need again. See here in my down in my console that here in armor down, you are going to see when the R is processing the document and some message. I'm here want to say something. R is a language that is really talkative. They like a lot tell us what is going on. And he really wants we pay attention. So every message is in red, even the good news. So I know that is not natural because you say if things go okay, most of the time you expect a green message. Not with R, you're going to get everything in red, but that doesn't mean that something goes wrong. And the only moment when something goes wrong is when the error word, it is a beginning of the message. So that means that the code don't run and we need to check what is going on. Then we have warnings like the one I have here. And most of the time it has to do, for example, with missing values. So the codes run, we have the result, but R is telling me, watch, because you have some missing value here, so be careful about this. And the other that don't say warning or error, I choose message sharing what is the status and how everything is going. Because as I say, R is a very nice talkative language. So we are going to see some little details about the report and the code we are seeing there. So for example, the first chunk of code, we are going to do everything what we see here in the next steps. We are reading some data. Here we are doing a summary. And here is when we do the table that we see here. For the plot, again, we have the data frame, we all the penguins data. We say here that we only want one of the species, Chen2. Then we do a plot. ggplot is the function for doing a plot. We add some data from the axis, from the title. And this is the result of this code that is here. Which is awesome about this, is that we change the data because we have, for example, more data about penguins. We run the code and the plot is going to redraw without any other need to do anything. In a spreadsheet, most of the time we need to or refresh or to do the plot again, then to copy and paste to the report. So this is one of the things they are going to save some time for us once that we have what the plots and what the tables and what the summary we want to for our work. And this other one, again, is a ggplot. Again, is we only want this for the Gen2 species. We have a ggplot again with another kind of plot. So we are going to see this in some details. As you can see, the chunk code start with these 3 backsticks and then these brackets and the letter R, that means that the language that is here is R. Why? Because we can have other languages. So we can have R, but we can have Python, SQL, and other kind of languages, which is also very powerful because we can mix languages and text as we need. Questions, comments, feelings about this? I haven't. Okay. It's amazing. I'm so clear explaining. Because everything is clear. Please ask. Yes, Kirsty.
So when you say you can mix R and Python, I mean, do you have them in separate codes, or can you genuinely mix them? Like,
yes, I understand when the when this need is going to execute each language in what they need. Our studio is doing a hard work to integrate Python inside their pipeline. So yes, Pau.
One thing associated with that is that you can have R chunks, R code in chunks, or Python code in chunks, but you cannot mix both.
yeah,
And unless you use some explicit packages that can talk with each code, you won't be able to use variable from Python to do R things, and vice versa.
okay. I don't think my head could cope with doing both, but it's interesting. Thank you.
No, thanks to you for the question. Okay, so Paul, I think we can make the break now, or we can follow reading, or you tell me what you want to do.
So we can use this next 5 minutes to create the file we are going to work in the next few hours, and then we have a break. So we use the time, and also we have some time to rest. Yeah, that's okay. Great.
Okay, I stop to share my screen and I let you continue.
Okay, so I'll share my screen now, and I have the same as Johnny and also as you. Let me know if the size of the everything is okay, or if I should do some zoom up. Great. Awesome. So we have this example report, and our goal now is to learn what is inside, to be able to reproduce that and to understand what is doing the code, and maybe in one day use that for your analysis and reports. So I will invite you to create a new R Markdown file so we can make notes and try things. And we have the report there to rest for a few hours until we come back to that. To create a new file, there's many things, many ways to do that always, but you can go to the bar menu on the top of Arc Studio and click on File, New File, and the third option is Arc Markdown. So I'll now press Enter or click on that, and you need a title, and maybe you come up with something better, but maybe notes during the workshop. You can also add your name if you want, and we'll talk a little more about output format at the end of the workshop. So now we are set to click OK, and you have this template here that it's open to the side of the Penguins report. This template also helps you to understand how this type of files works. We won't need that because Tony already did a great job to explain what is on this type of files. So I'll select everything and delete them. Why I didn't delete these parts? Because the header is important. We need that so the file will know how to behave. And we also need this first chunk code, so the code will know how to behave. This is the chunk that that control how the code will work on the file. So we leave it right how it is. And in the few minutes we have, we're using this penguins data that we really liked because penguins are awesome. This data came from the Palmer Station in Antarctica, and the data set usually is called as Palmer penguins. You can find it that way on the internet. And in R, we have some R packages that include the data, and you can install those packages to use that. In our case, we exported the data to a CSV file and also to an spreadsheet. So we will learn how to read data from those files. But if then you want to use the data, you can go install the package and use the data directly from R. So what about that break? So we'll have this break and then another one at the same time in 1 hour. So you can plan your morning or afternoon. And on this 10 minutes of break, we'll ask you if you can to not to change from this screen to the cell phone screen, take a break, walk, or do something you need. And if you have any comment, any question, any doubt, please save it for after the break. We'll tackle everything together.
So should we meet people back here at 3 p.m. UK time, GMT? Yeah.
Yeah,
O'clock.
the idea is that you don't need to go to the you don't
The
need to
meeting.
close Zoom. Just turn off your screen and we'll see you in 10 minutes at the top of the hour.
Go to see the cat, put water on the plants, do some yoga, watch the sun on the window, and we wait again.
Hello. As you can see, I added a very fancy clock to my art studio. We don't need you now. We'll continue. So hope you are there. You can say on the chat if you are there. And we'll continue now, as I said before, with any questions you may have, or any doubts or comments. Now is your turn. You can raise your hand. You can write on the chat. Seems like we haven't done enough to have questions, but we'll do now. We'll start with the fun part of coding. And the first thing we are going to do is read data into R. And for that, you have many options. R base, the code and the tools you get when you install R are sometimes enough to read CSV files and text files. Here, we are going to use some package, some R package that you have already installed on your RStudio Cloud project. We already done that for you, so we can work now and don't worry about installing problems, something like that. But even with the packages already installed, you need to tell R that you're going to use them. So how do you activate the libraries? That's the first question to start using the tools. I'll write on this first time code I like to do all these setup things on this chunk, so I have everything organized on the file. You can do that on a new chunk if you want. And I'll activate the first library with the function library. You can see how RStudio starts telling you what to write. And we'll use that because I'm lazy and I want to write less. And we install for you tidyverse. This is not a package per se, it's a group of packages. And in particular, the one we are interested in now is readr to, as you can guess, to read files. See, this is a comment. Everything that goes after the hashtag on a chunk code is a comment, and R will ignore it. And the other library we're going to use is readxl to read spreadsheets files into R. To run the code, you can press this little green arrow you have on the top right corner of the chunk. I'll do that now. As you can see, a green line appears, and now I have the libraries activated. But you could also use Control Enter to run the line that your cursor is, or Control Shift Enter to run the whole code. We'll keep repeating this all over the workshop, don't worry. So now we have the libraries we need. Let's start doing some coding. So reading, let's do a level 2 title, reading, sorry, CSV files. And I'll add a new chunk code chunk. And for that, you can use this button and choose R. So a new chunk will appear. You can type the backsticks and everything, but a button or the shortcut is going to be more quickly. The data is stored on the data directory on your project, and we encourage you to use projects and to organize your analysis in this way. We have only one directory that contains the data. Here we have two versions of the same data set in two different formats to work with, but you could have more information, and you could have other directories to store different things. For example, the results of your data analysis could be in a new directory. You could save figures in a fig directory, and so on. So now we have the libraries activities. We can access to the functions that contains. The one we are going to use is called read, and this thingy, sorry, I don't remember the name, CSV, because we are trying to read a CSV file. Parentheses, and then in quotes, the location and the name of the file we are trying to read. In this case, our file is in the directory data / the name penguins, and if I press tab, it's going to give me the two options I have. I'll press enter now, and everything is now completed. Control enter to run that, and we have read our first data set into R. Here we have some kind of a pre-visualization of the data. We have many columns, 8 actually. Here's the structure of this tabular data. 344 rows, and that is associated with each penguin we have, and 8 columns, 8 variables that include the species, the island where the penguin was found, build length and build depth is associated with the face of the penguin, and we have some other information. What we did here is only visualize the data. We haven't stored the data into our object. To do that, we have to use the arrow operator to assign this result into an object to be able to use it in the future. So I'll modify this line code and write penguin. I hope I'm writing that okay. And the assignation operator in R can be the common equal, or as we liked, the arrow that probably you will see in probably many R codes over the internet. To make this arrow, you can use Alt and dash. So that's another shortcut. And what this is going to do is read the data and store it on this R object. So if I press Control Enter again, now I don't see the previous visualization because went directly into this object here in the environment. What we can see is this summary of the information are just read, the type of data we have in each column, and some other information. If we have more columns over this message will be longer too. What can we do to see the data if we do this? We could just press the name of the data into that is located on the environment, and a new tab will open with all the information. See, this object in R is called a data frame, or where we're working on the context of tidyverse, this is a table that is a data frame with some small differences. What we did here by pressing the name of the dataset here is running this code you have on the console on the bottom of the screen. See, view with capital letters, penguins. Thank you. I just saw that the thingy is underscore. Thank you. And at the same time, as we can see the raw data here, we could also use a function to glimpse the information we have. Of course, glimpse is the name of the function, and all the functions try to be like explanatory. So if we can see the data, we use glimpse and the name of the table we are using, penguins. And again, RStudio try to help me. I press enter to complete that and control enter to run the line. Here is the glimpse of the data. And this is interesting because it gave us the type of data, and it's sometimes useful because sometimes R doesn't understand the type of data we have on the columns. Sometimes we have numbers and R interpret that as characters, and sometimes we have dates and R interpret that as characters also. So we need to look at this at the beginning, so we know if R is doing its works, or we have to help the functions to understand the data we are trying to read. So how about reading spreadsheets, the thing we are here to work with? I'm just thought a typo there and a typo here, sorry. Reading in this scale XLS files, and I'll do some enters here so you can see better my screen. Again, we need a chunk code to work with. So in this case, I'll use the shortcut Control Alt E to use shortcuts. For me, using shortcuts helped me also to make less typos because everything is done by R and RStudio. And to read this type of files, we are using the library we activated here. This is for Excel files. And the name of the function is read. And here you have a few options. Read Excel. This is like a generic function that will try to guess the file and the format of the file, if it is XLS or XLSX. Is smart to, or try to be smart to understand the format. So we are trying to use that. But you also can be more specific and use read X, use the function read underscore XLS or XLX. Sorry, it's difficult. So here again, we need to say where the data is located and what's the name of the file. So again, my file is in the directory that's called data/penguins. But now I'll use this one because it's the one we are trying to read. If I press Control Enter, the code is run, and we have again the same exactly data we already saw. This is a very, very friendly file we created for you. We won't find those friendly files in real life. We'll find some spreadsheets that have different sheets, that have data in very strange data range and things like that. So how are we gonna deal with all those possible problems? This function we are using have arguments, options to solve those problems. And we usually don't remember all the possibilities that each function gave us because it's impossible. So to see what we can do with the function, we use the documentation. You can find the documentation online, but you can also access to that inside RStudio. One way to do that is clicking on the function. So the cursor is going to be on the name of the function, and press F1 to open the Help tab on the right bottom corner of RStudio. The other way to do that is, and this I prefer to do on the console, is type in a question mark and the name of the function, read underscore Excel, and enter to run that and open again the documentation. So I invite you to do the same. So you have access to the documentation. And I have a question for you that I will ask you in a minute. For now, we have here documentation, the description, the usage, and here you have a family of a function that usually happens because functions are sometimes similar, and we have the documentation for all the family. The argument, these options I was telling you about, and then sometimes some extra details, and the most important part, the examples. These are the things that usually save my life when I try to understand how a function works, because it gives you examples that you can run on RStudio to see what the function does. So if we have a file that contains two sheets, one that is called Gen2, I will say Gen2. We can rename the penguin, and other with the data from Adelie, the other species. We can ask this function to read only one of those sheets using this argument here. So in this case, the default option is null, so it will read the first thing it appears on the file. But if you want to read other sheets on the file, you can write here the name of that sheet to read it instead of the first one that appears. And if you want, for example, to read only one, only a small range of cells, you can also do that with the range argument. And we will do that in a sec, so we can see what's the result. To add more options to the functions, we use the comma to separate all the arguments, and then we tell R what's the argument we want to use. In this case, range equal to, and now it's our turn to see what we want to read. Let's say that we want to read the I'm inventing here, maybe the A1 to the E20 range, and these have to go between quotes. So R will understand what is this about. And if I try to run this with Control Enter, now we have only 5 columns because I read the A up to E column on Excel, and 19 lines, 19 rows, because one is the title or the head of the table, and the others 19 rows are the data. Yeah. So now we know how to deal with some more complicated Excel files. We, of course, can find more things to complicate our life, but we'll stop here to continue with more beautiful things on art that are the figures and plot with ggplot. Any question about reading files in R? I see one thumbs up and nothing else. We continue. And this is my favorite topic, so stop me if I go rambling for 2 hours.
I will
So,
let you know. I will let you know.
thank you, Chani. I have a hand. Almudena, please.
Sorry, I'm very slow. I type very slowly. So
worry.
why do you have to put like data slash before the name of the file?
Great question. I need to know where the file is. In my case, I'll go to the File tab.
Okay.
I have this directory. You also have this directory. So I need to know from the top of the project we are where the data is. In this case,
it makes
it's like
sense.
data slash the name of the file. If you have everything on the open without any directories, we don't need anything else besides the name of the file.
Okay, yeah, it makes sense. Sorry, yeah, it was. Okay,
Great.
thanks.
Don't worry. Every question is welcome here. Well, now to the plotting data. I'm trying to organize the file, so everything is under some kind of subtitle. But on the web page we created with Johnny, you have everything, and probably more organized that we did, and clear that we can say here. So this is going to be forever there. You can save the link for the future. To visualize data, we are going to use the ggplot2 library that is included on this tidyverse library we just activated before. So we don't need to do anything else. R knows that if I call ggplot2, it's going to be ready to use those functions for us. Here we are going to concentrate on the first plot we have on the example report. If we have some time, we can try to understand the second one, but the general idea of ggplot2 is to build a plot with layers. We'll have our first layer that is the area of the graphics that will be drawn taking into account the variables we will use and the range of those variables. And if the variables are numbers, the area of the graphic will show a continuous axis. If the variables are categorical, we'll have something different. And then we'll add some elements to the graph, to the area of the graph, the geometries. In our first graph, we have points, and we'll use that geometry, but ggplots have, I don't know how many geometries to work with, like dozens. So it's really flexible to work with plots, to explore the data, but also to communicate with those plots if we add some details to make it look clearer and also more beautiful. So again, a new chunk code with Control-Alt-E, or if you prefer, the button here, this green button, it also helps. And we usually create the plot in one chunk code to like add layers after layer to create what you saw on the example. But now I'll do this in step by step in different chunk code so you can see the whole history of the plot. The first layer is the area of the graph, and we build that with the ggplot function. The first thing that this function needs is the data. So data equals to our penguins data frame, comma, the second need, the second thing ggplot needs is the variables. And with variables, I mean the columns of the data frames we are going to use for the axis of the graph. So we use the argument that is called mapping, and I press enter to autocomplete. And the function as that came from aesthetics to say that we want in the x-axis the bill underscore length underscore variable, and in the y-axis we want the bill underscore depth underscore So what we have here, first, the data we want to use, and second, the variables we want to draw on the axis of the graph. We use this function to tell ggplot to look for these names of columns on the table, on the data frame we just mentioned before. So we are going to map these variables to the area of the plot. I'll stop talking and run the code so we can see what this does. Okay, so I have the first error. This happens all the time. Let's see what the error says. It says bill length not found. It's not finding this this variable. And I found the error. I always type length in the wrong way. It's th, not the other way around. I'll try again without typos. This create the area of the graph. We don't have anything on the area because we haven't tell ggplot what we want to do with that, which geometry we are going to use to represent the data. We are going to do that now. And I'll start to copy and paste it in a bit, but for now, let's write that what we have again with some little changes. So the area of the graph, again, ggplot. We don't need to say data equal to. We can just set penguins, comma. We can also ignore the name of the argument because R and ggplot now knows that the second argument is always the as function. And on X, we'll again want the bill length, and don't let me write that wrong again, comma, bill underscore depth underscore So this is going to do the same as before. We have the area of the graph, but we simplify the code because we don't need to say data equal, mapping equal, x equal, etc., etc. ggplot is smart enough to know what to do with everything if we respect this order. Now we can add the geometry layer. And to add layers to a ggplot plot, we use the plus operator. And we could keep writing in this line, but I like to press enter to do everything, every layer in each line, so it's going to be more readable. And the geometry is geom point, as I mentioned before. Enter to autocomplete because I'm lazy, and control enter to see what produces. And now we have the data. We have the relationship between the bill length and the bill depth. So the form of the face of the penguin, more or less. It looks like we have some groups here, maybe some penguins that are similar to each other. Here we have another like cloud of points, and these from here are suspicious also. So we may have some height distribution or height pattern that we are not seeing here with only these information plots. We have another like little window here. If we press this, we'll see a warning. This warning says that there are two missing values that ggplot just ignore, but is telling us that we should pay attention to that. So some of these variables we used have missing values on it. So when there is a missing value, ggplot cannot draw a point because it doesn't know what a missing value is. So it ignores everything that is associated with that. We won't worry about that just now. And now is the point I'll start copying and pasting. So you can do the same. I'll copy and paste this chunk code to modify a little things to start building the plot you saw on the example. For now, we have this, and we just saw some patterns that could be hid inside this point cloud of points. And one way of trying to see if we have something going on here is to add a new variable to the plot. One way to do that is associating the aesthetics of the element of the graph to a variable in our data frame. For example, we could paint or color the point taking into account the penguin species. To do that, we need again to use the as function. So ggplot knows that everything that is going to find inside that function is located on the data frame. So we want to change the color of the point. We add some options to the geom_point function with as parentheses color, or if you prefer, color is also an option, equal to the column of the data frame we want to use. In this case, I think it's called species. if we don't remember that, because we usually don't remember all the names of the columns of the data frame, we can come back to this tab here where we have the data. The name is species, so we can use that. And if we run this, we'll come up with this. Now, the red pinky colors are the Adelie penguins, the green ones, the G-strap, and the blue ones, the Gentoo. And we can see that those cloud points are associated with the species. It doesn't surprise us that each species have a different type of face, if penguins have face, and are different from the other species. So we have here this relationship between the depth and the length of the bill. We could also add new geometries, new layers to this plot to emphasize that relationship. One way to do that is to add a model, in this case a linear model, to see if we can fit the data to that model. So again, copying and pasting here so we can add a new layer, a new geometry to the plot. Again, we will usually do everything on the same chunk code, but here we want the whole history of the plot. I'll type a plus so we can add a new geometry and enter to do things tidy. And the geometry to fit a model to the data is called geom underscore smooth. And we could go to the documentation of the function with F1 to look what options we have. And in this case, we have many arguments, but the one we want to see is the method. This method will allow us to use a linear model or any type of model available for the function. So we have GLM, GAM, LOES, or probably others that are not mentioned here. We are going to stay in the more simpler model, the linear model. And to do that, we'll tell the function that the method is equal to, in quotes, LM, so for linear model. And we want to do that for all the for the different species. But before doing that, we'll run the code so we can see the results here. If we try to fit all the data without taking into account the species, we'll have some kind of relationship that is going in the probably opposite direction of what we saw or what we thought before. Here is saying that probably if the depth is bigger, the length is going to be smaller, and that doesn't make much sense if we look at each species independently. So how can we fit the data for each species independently? We could do the same as before. We could say that the color associated with this geometry is related to the species of the penguin. But we are forgetting something here. If you do this, if I do this, ggplot, we won't know where to look for a species because we are not using the as function. So I'll go ahead and add that, add that to the function, and now run the code with Control Enter to find the result. Now we have one linear model for each species. And now we can see that the relationship is the opposite. If the depth of the bill is greater, the length is going to be bigger also. So as bigger as the penguin, as bigger the face or the bill if you want. We have a few minutes left to make this plot look prettier than now. These colors are the default colors for ggplot and are not the best. We have so many color palettes to choose from, and we could think for who is going to see and analyze our plots, our analysis, and keep in mind that some people may don't recognize or distinguish between some colors. Some of them will have to print our plot. Some of them will not have a color printer and will do that in black and white. Or maybe our plots is going to be photocopied several times and we have to take that into account. So there are so many things we can think and try to prevent when we are trying to make our graph prettier. So we could talk about color palettes and different things we can do to improve our plots. But I decided to stop here and use some specific colors that the person that created the data set and published everything used, Alison Horst, because the colors she used are beautiful and I like them, and it's a way to learn how to include manual scales to a plot. So let's copy this.
You have some questions on the chat, Paul, if you want to check.
Thank you for letting me know that. What is that's great. What's the mean of LM in this code line? LM comes from a linear model. So here we are saying to GeoSmooth that it should apply a linear model to the data. We could use other methods that are included on the documentation, but here we are keeping things as simpler as possible because the statistic part is not the goal here. Why it's in green? Great. RStudio use different colors to highlight different parts of the code. It's in green because it's in quotes and it's a character element. The parentheses, the plus are in gray, and you could, if you want, change the theme of our studio and see the code and the text in different colors and also in different fonts. Here we are using the vanilla theme, the default configuration that it came when you install everything. There's something else I missed, Johnny, on the chat?
Perhaps to check, to show where people can see is the penguin data frame loads in the correct way in the environment. Can you just show again when you read the file with the read CSV or with the read Excel, the object has to appear on the environment. So that's the way you check that our read all the data in the correct way. And then you have to write on every single function, in this case, the ggplot, the name in the function as a parameter equal as the name that's appear on the environment. So otherwise, it's like when Pao run the length. Yes, so it's going to, you say, this is here, why they tell me that it's not here? So we can check because it can be a typo, which happens every single time, happens very often. So can you show again, Pao, how to check that they read and have the data frame?
So here's the line that reads the data. Uses the function read underscore CSV, and the data is stored. And that's the reason we have the arrow here on penguins. This R object that is also present on the environment. The environment is the panel that is on the upper right corner of our studio. So sometimes we read the data, we have the object here, but we don't know if the data were read by R correctly. So we can press here on the name of the data to open this tab to see what R did. In this case, it read all the columns. We have some missing values here, and actually 344 rows that correspond to each penguin. So that's the way we can see if we read the data into R correctly. And the other way to do that is to use the glimpse function. This is going to give us some kind of information about the structure of the data, the type of data we have in each column, and some pre-visualization of the first rows of the data. So if you have penguins on the environment, and if you type it right, I won't do that every time. I usually use the tab a key on the keyboard so RStudio will complete the word for me, and I won't type anything wrong. You should be able to use it. So I'm seeing many questions on the chat. I'm happy about that. I'm happy about the questions. So we should take a break, and then I can continue for a few more minutes, Johnny, to show what to change the colors of the graph, to answer some questions, maybe when we can answer some of the chat, and then come back to see everything else.
Yeah, we have nice questions. So
9 questions, great. Well, take a break,
and
people.
nice questions.
We'll take a break to the top of the hour. I'll look for my nice clock and see you in 10 minutes. We have take everything in our hands with Johnny and start answer the questions on the HackMD document. So everything is going to be there, and you can come back later to read the questions and the answers. And I hope that helps to you. And of course, if you have other questions, every question is welcome. And Johnny, do you see any question we need to answer here now?
Can you show how to execute a chunk without the shortcut? Can
Right,
you show with the
of
play?
course. I will minimize the console so we have more space for the file. Here we have a chunk, a code chunk, and on the upper right corner we have these buttons. We'll talk about this one in a bit, but this one, the green arrow, is used for running the code. If you click on this button, you will run all the code for the first line of the chunk to the last one in that order. So that's another way to run the code along with the shortcuts. Thanks, Johnny. Well, I don't want to take more time because Johnny have some interesting things to show. The things I still on you, or I want to show you, is the how to change colors and maybe how to change the theme of the graphics of the plot, because you already asked for that on the chat. So to change colors or to change the appearance or of any element of the code, of any geometry or the axis, or pretty much that, we use another layer of ggplot that's called scale. So we have a ton of functions that start with scale underscore something. In this case, because we want to change a color, we use underscore color. And you probably have color also, if you prefer color instead of color. And then underscore, and this will vary between scales. You will have the name of a scale. For example, Viridis is a scale I really liked. Or you can use Brewer, que is another family of scales that we use a lot in ggplot. But now I'll choose to use manual because I want to say what color is going to be for each species manually. With parentheses, we now have to add the values, and the values are the colors we want to use. Equals to, and here we have to say to ggplot the list of the colors. This is a vector. For that, we use the function C, the concatenate. These functions will create a list of, in this case, colors. And you can use the name of the colors, and you can Google the hundreds and hundreds of colors that ggplots are able to use, or you can use the hex code of the color. In this case, I'll use the color names. I like dark orange. And you can see this is going to be in quotes. I like the purple. And I will use also the cyan for. These are not random colors. I choose it specifically for this because they're very nice, at least for me. This new layer will change the color of the points and also of the smooth geometry, because both have the color aesthetics activated. And here we have our very, very nice colors for each of the species. If we wanted to add some text to the plot, something like titles, or change maybe the name of the axis, because they are not very nice right now because it takes the name of the table, we can do that with a new layer using the labs function. And in this case, I will cheat a little. I will pass the code to you on the chat so you can use it with me. And I will also paste it on the code I have, because there is a lot of text. We have a title, as subtitles, the X and Y axis labels, and also the shape. Sorry, also the color of the points and smooth. I'll run this, and now we have the penguins. Penguins build dimension as titles and also as subtitle, and we change also the name of the axis. The last thing I want to do, and I'll leave it to Johnny, is to change the theme of the plot. This plot is using the default theme that is called theme gray, and that's the reason we have a gray background here. But ggplot has 8 themes to use, and you could also install other packages to access other themes. For example, Johnny says that her favorite one is from the BBC. So you could install that package to use the style of the BBC. My favorite one is minimal, that is from ggplot. So I'll add a plus to add a new layer with the theme. In this case, theme minimal. And here you have many themes. You can choose between them. If you want to use another one besides theme, minimal, you can do that. Enter to autocomplete, and we can run the chunk with the button here. And that's it. We have our plot with a very nice theme, a white background, and some nice colors too. Well, Johnny, it's your turn now. I'll take care of the chat and all the questions, and I'll stop sharing my screen now.
Okay, there is some questions that perhaps you can help Martina with some error in the code. Okay. Now that we read our data and we did some plots, we are going to show you how we can do some summary, some calculations with our data. That is the idea. So I'm going to share my screen. I'm going to resume my from spreadsheet to our project. This is happening because our Studio Cloud, it is free for, I think, the 15 hours a month or something like that. So when our Studio Cloud don't see any activity, resume the project so it's not consuming resources on the cloud. So that's also can happen to you. So here we are again. I'm going to do the same as Pau, so perhaps someone can remember me how we create an Markdown document, because I forget it, and I need a new blank Markdown document. Come on, can anyone help me? You can unmute yourself and tell me what I have to do. Click. We use the menu. you can write on the chat, but if you have to do a new Armadan document, where you go?
Well, you go to File, don't you? The top left.
File, and
New-
there,
New file.
exactly. Yes, and we have a lot of options here. And the third one is an Armadan document. Thank you, Jacqueline. So here we add the title. So we are going to have here some data. Manipulation, author Shani, which is the way that everyone's called me. And here we have a new Armadan document. So the title, as you see, is the one who showed here, is not the name of the file. So until we don't save this file, this is going to be untitled, and then we can choose the name. So I'm going to delete everything that this template show us, and I'm going to start from scratch. This is a blank, clean Armadan document. So if I need to start from scratch, one of the things that I'm going to need is to load the package that I need to use. Yeah, the packages are like an app on a cell phone. I have to install once, and then every single time I have to use WhatsApp, I have to click on the app and open. Yes, and load to my memory. The package is exactly the same. I install once time, and then every single time that I have to use, I need to click on the package and open. That I do that with the library function. So I'm going to use tidyverse, which is the set package we are using. And for now, I'm going to use that one. Let's see if we need something else in the future. So I'm going to execute this, Control Enter. And now I have everything that tidyverse functions ready to use. And we are going to do some calculations and tables. We are going to try to recreate the table that we have on the report, on the example report. So tidyverse has a lot of package inside. Right now we use the reader to read the data and ggplot to plot our data. But I have a lot of other packages that I hope I'm saying okay, the names, but because they're pretty funny. Tidyr, dplyr, and I don't know why they use these funny names, but you can see that every single package in R has an R in some place of the name. If you don't find an R in the name of the package, it's not an R package. It's kind of tradition right now. So we are going to use some functions that are calling also verbs that allow us to do handle wrangling our data. The idea is to take the penguins and to do a summary. So the first things that I need before to use the penguin is to read the data. So I'm going to add a chunk, and I'm going to, yes, penguins, the assignment operation, and then read CSV data slash penguins.csv. Let's see if this works. I have this outcome that tells me that the data was read it and load to the penguin object. I have here in the environment the penguin object. I may click there and I can see the data frame, all the data that we have here. So let's see how the table of the report looks like. So we know what we want to do. So the table has one row per species, has a count, the number of cases for each species, and has the average, the mean of the body mass. So let's try to do this calculation. We are going to use the data in penguins, and we are going to use this nice symbol here that is called the pipe. And what this means is that we are telling R, take this data that is in penguins, and then we pass this data to the next function. So it's like the idea of the pipe where we are going to pipe one step after the other, and the result of the first function is going to be passed to the other function. You are going to see a lot of this pipe on code and R code. So the first things that we need is to group or summary the data by species. So the functions that allow us to do this is the group by verb. Tell me in the chat if someone here used databases and no SQL. Tell me a little bit about you. I don't know, SQL, it's also SQL, that one. Let me know about if you use that and you work with databases and that language or not. You say, Shani, I don't have idea what is that. That's okay. Okay. When you learn how to use the tidyverse and this verb, then it's going to be very natural to understand SQL or SQL because it has a lot of there are equals in the way of reasoning this kind of operations. So the SQL is used in databases when you listen to Postgre or PostGIS or Microsoft SQL Server or SQLite or SQLite, Access. All of that are management system for databases, relational databases. And the SQL is, I don't know why people say SQL, for being honest. I think that is some name that stayed on the community, but it's, the letters mean structure query language. That is what SQL means. So it is a language to query data from a database. And this has a lot to do with that. So the first idea is we need to summarize by species. So the group by verb, we are going to tell, take all the data in penguins and please group by species. I choose the other. And then we say that all the calculations we are going to do, we need to group by species. Then we can say what kind of calculation we want to do. And for that, we have another verb that is summarize. And we can use there a lot of functions to get this summary. We can calculate max, mean, means, count. We can do calculations between the columns, between the variables of our data set too. So the idea here is to count how many cases we have for each species, which we are going to save in a variable named count, and the n functions do that, count how many cases do you have for each one of the groups you are doing. And then we have the mean of the body mass. And here is something that I want to say about name of variables. Please try to use names that help you in 6 months or 1 year to know what are you saving there. I mean, don't use variable 1 or X as I used in the first example, because at least that X is really meaning in your discipline, in your domain, then use a name that's going to understand you what we are saving in this variable. And when you name things, and this is perhaps more useful for people that language is not English, don't use special characters. Don't use the ñ. Don't use letters with an accent. Don't use a space. Please use this underscore or some way that is going to be nice for a computer to read, because these other symbols can be really tricky and it's going to give us some problems. So it is more easy if we do this way. So the functions to calculate the mean is mean, and we pass as a parameter the variable we want to calculate the average. So it is body mass G. Any questions about this code here? Something that you say, I don't exactly understand why we write this in this way. This is the data and telling take all the data in penguins and please pass these to, and then group by species, and then summarize the count and the average of the body mass. Yes, the pipe. The pipe is a function that is also in the tidyverse. It is in the Mahidra. I don't know how to say that one, but there is a package that have these symbols, and it is a way to say, take this that is on my left, and the result of this pass to what is on my right. So here I'm taking the data and I say, take penguins and then group by species, and then summarize count and mean body mass. And I can add another pipe here and say, and then do other things. And we always going to take the last result. So here's in penguin as a full data set, but then we group by, so summarize are getting a group by data set, which is not the same that penguins as a whole. And if we have a pipe here, the next functions are going to get only count and mean body mass, are not going to get all the penguin. Is that make sense? Okay. I'm going to execute this, to run this. And here we have the table, but we have something different of what we have in the report here. We have 2 rows with an A in as a result of the mean. What happened here? That we have NA values, we can see here in this column. So when R is doing the calculation, if you have an A as a value, you are going to get an A in the calculation. So we need to remove this if we want a number result. Most of the functions to do calculations have a parameter, which is an A .rm that you can put in true. So these tell to R that please make the calculation without taking into account the NA data that I have in this column, in this variable. Let's go to do this again. And now we have a result for every column. This is something that happens a lot. I don't know, at least in my data. I don't have data without NA. I have a lot of missing data when I work. Okay, one question for you, so you try. What happens in this code we don't group by? So try to take this code and remove the group by part. I'm going to copy this on the chat just in case. And remove the group by and execute the code and tell me what you get as a result. You can unmute or you can write on the chat. Exactly, Laura. If we don't group by, we get all the calculation, all the summarize that we are doing is going to be for the full data set. Yeah, it's going to, yeah, exactly. Bernadette, you share this only with me. If you want to check in the send to on the chat, choose everybody, and then you share with all the group. Awesome, awesome, thank you. So I hope this helped you to understand better how the pipes work and how the group bys work. We can group by whatever variable, categorical variable we have in our data frame. And if we don't use group by, we are going to do the calculation for the entire data frame we have. No, it's okay, Bernard, don't worry. I like your results, so I want you to show everybody. Okay. Any questions here? You're doing me here, and I'm going to move on. Okay. If we check the, let's go to see, I have here the table. We can see that the numbers in the body mass are different. We are not seeing this in like in thousands. We are seeing this in a one-digit number. So how we are going to fix that here? Well, we can add in this part of the code, we can add also a calculation. So if we divide this by 1,000, we are going to have the number in kilos and not in grains. So if I run this again, then I have the difference in the number. So we want to show you here that you can also make calculations, and you can make calculation between variables too. So if you need to do something between body mass and build depth, for example, you can write your formula there to work. Well, now that we have our table, let's going to try to format like we see here. And for that, we are going to use a function that comes in a package that is called knitr. how hard is to say this? That is like the neat, but with an R at the end. And it is the package that allow us to do our Markdown stuff. So we are going to write. We can do two things here. We can save this table in an object, or we can use a pipe and pass this table to this other function. We are going to save this in a variable just to see. We're going to call summary. If this were in Spanish, we call this tablita, which is little table. But I'm sure I'm trying to teach you to have meaningful names. So please name also the table with a name that help you to remember what you saved there. So I'm going to execute this. And now if you see, we have a summary here on the environment. And if I may click here, we have species count and mean body mass as a data frame. So we have also this data ready to use here. And now we are going to use summary. We are going to use the pipe, and we are going to pass this to the knitr package. We are going to talk about now how and why I'm writing here, and use the name of the package 2 times the, how do you call that? Dos puntos. Selena, help me.
Colin.
Colon, okay, 2 times the colons. And then we are going to write the function, which is cable. You are going to see this sometimes in their code, and this is the way we can use a function of a package that we don't call with library. Remember that I tell you early that we need to load every package we want to use every single time we start to use it. So we write library and tidyverse, or library ggplot2, or library reader. So I don't write in any place library knitr. So as I want to use the cable function of the package, I'm going to write this way. And you have to do this with every single function of every single package that you have installed on your R in your computer. This usually is used when you're going to use only a function and you don't want to load all the package on memory, or when you have two packages that has a function with the same name and you want to be sure that you are using the function of this package and not of the other one. That can happen sometimes. For example, you have a package that has an implementation of the function means, and you want to use that implementation and not this one. So you write the name of the package 2 times colons and then the name of the function. Is that clear? Yes? Okay. Well, what we are going to do now is as we made our plot pretty, we are going to try to make our tables pretty. So the first things we're going to say is to give proper names to the columns, because right now the names that show us are the names of the variables here. But in a table, in a report, I don't simply want to see mean underscore body underscore mass. So we are going to want something more like species, starting with a capital letter, count, and mean body mass, for example. It's going to be more nice. And the other things we are going to add is a title, that the function is caption equals, and we can write the title there. summary of penguins by species. And we're going to try to run this code to see. Oh, I have a warning. I write some. Yes. What I did here is I forget to add the C, which tell to call name that it is a vector of value. So I'm telling that for each column, this is going to be the names that this column is going to have. A summary has 3 columns. I give in a vector of 3 elements, character element with these values. And I forget to add DC. So let's see now if I don't have any other mistake. Now, here is the table. It's going to be nice when I knit the document. I hope. Let's knit this. I'm going to click in the knit button, and it's going to ask me what is the name of the file, because every time I knit, I need to save the file. So I'm going to add here summary, save, and now we are knitting the document. And here is all, when I read, all the code, and here is the table that we just create. It's really nice table. Okay. Now, two more things that we can do with our data. We have a lot of verbs to work with the data. We want to show you one more that we are going to need to understand all our report, our example report. And this one is how we can filter data, how I can make a subset of my entire data frame. So again, I'm going to take penguins. I'm going to write the pipe and to say, take all the penguins and please filter penguins, and which is the column, the variable that we are using in our example report. For what do you think we need to filter? It is by body mass, it is by Iceland, or it is by what? I'm going to go back to the report. So we have a report that appears to be focused on a species. Yeah, we have Gentoo in a lot of places. So if I want to filter by a species, I can add this column, and I need to use 2 equals, because here I'm not assigning a value to a species, but I telling R, please filter all this data when the species is equal to this value they're going to write here, Gentoo. So what this code does is that we are going to get every single row that for what this condition is true. It's like when we use on Excel the filter function that we have, and we check one of the value. Well, this is the same. So if I run this code, then we can see that all the species are Gentoo. If I change here, Barbijo? No way, because I think that is in Spanish. I'm going to copy here a day. We're going to copy the other.
I think barbijo is chin strap in English.
Okay. Okay. We use the data set in Spanish too. So
And it's funny because in Spanish, barbijo is face mask also. So
it's pretty on move. So if you can see now that I changed Shentu by Adele, now the outcome only show me when the species is Adele. I'm going to invite you to try this filter function with another variable. So try to write a code for filter the penguins that the Iceland is this one. I'm not going to try to say this. I'm going to copy on the chat. So try this one and let me know what should I change here to do that, to try to filter but that Iceland, Torgersen Iceland. Hey, excellent, Sarah. Thank you so much. Yes, exactly. I saw the Tamides was answering me on the chat and I didn't see that. That's why by species. So yes, thank you. And you can also filter by a numeric variable, and you can use all the symbols, all the logical operators, greater than, less than, equals to. You can use that with also with dates, with variables that are dates. Okay, Pau, we are almost on the time. So you want to show?
I can show some little things.
Okay.
Now we have the tools to understand what the example report does. We wanted to focus a little, and we won't take much time, to see what have we done in terms of this report to be nice, to be readable, and ready to share with others. So I have RStudio again to share with you. Hopefully you're seeing my RStudio, and we'll come back to the report. So we already been seeing what we have here, but if you may have noticed that when Shanice knit her file, she saw some code on that file. But here, if I knit, and if you do the same, you won't see code, because we have configured our file to not show any code, messages, or warnings, because we thought that, well, if we are going to show this as an example for the first time, maybe we can hide the code to focus on the nice results, the nice plot and table, and then we can talk about code. And that's the thing you will need to do if you want to share a report or a paper, and the people that is going to read it doesn't care about code, or doesn't understand, or doesn't need to know about it. So if you may remember, I told you that the first chunk code is used to um, to say how to set a file how the code is going to behave, to control what the code is going to do. And in particular, we have here some options of the chunk. That means that in this case won't show the code, won't show the messages, and also won't show the warnings. We could change this so we can see the code or the messages of the warnings, and we could do this for each of the chunks we have on the document. In this case, I did it on the setup chunk to change the behavior of the entire document because it's more quickly that way. But if you can, if you want to show maybe one code chunk just because you need to, you can change that using this little gear here that opens the menu and allows you to choose between the different options. If you, for example, choose to show the code and the output, the result of that code, you can choose here, clicking on that, and you can see that now something changed, and now that code is going to be seen or shown on the document. So you can choose between those things, and you can also choose between the output of the file. We used HTML because it's something that doesn't need much to work, but you could also choose between PDF and Word documents. And here to the side of the knit button, you have an arrow that points to the top, to the bottom of the file that opens a menu to see different options. We will quickly choose a PDF because it's really nice. And now it's doing its thing again, but instead of generating an HTML, it's going to generate a PDF. You may have if you did that, you now have a PDF on your computer. I can try to show you mine. Here it is. That, of course, it doesn't have much because it's an example report, so it doesn't have much. But all the information we already saw on the HTML and the source code is here. The titles, this table, and now we can see the code because I changed the configuration and then the plots and everything else. So
when
you can,
when I
yeah.
found out this, I just fall in love of R because I can also do this with a Word document. So I don't have to be copy and pasting from one kind of document to the other. So yeah, that was my first big, wow, this is nice.
I won't show you the Word document because I don't have Word, I have LibreOffice, and it doesn't show so nicely. You can do that on your computers, or maybe Shani can show us later, but it's the same. You can, from the same ARC Markdown file, create an output document with your code, with your analysis in different output formats. The HTML, for example, is useful to create web pages, as the one you now have for the materials of the workshops. The last thing I will show you, and sorry for taking so many time, but it's the cherry on the top of the cake, is how to automatize the report. we talked in a few occasions about how to change from Gen 2 to other species, and that it were mentioned in many parts of the document. If we want to change that, we have to change it in every part, or each time is mentioned. Now we know how to filter, for example, one species or the other, but we wanted to do this in one place only, so we won't make any mistakes if we change many things by hand. To do that, our Markdown has something that's called parameters, that are variables that we can create and define on the header part of the file, in this part, the part that is between these three dashes. And we could create a parameter for the species, the thing we are trying to highlight in this report. To do this, we'll add the params argument, and be careful with the indentation of the header. Here is trying to tell me to write below the HTML option, but we need to start from the left part of the document. And the argument is called params, column, and then on enter, and enter to the name of the param. We can use any name. We'll use something that is meaningful. Don't worry, Jenny. Species. And here we could choose. In this case, we'll use Gen 2. That is our first penguin. We'll change that later. And by doing this, now we cannot see that on the environment, but when R runs this file and create the output file, we'll have access to an object that is called params that saves or store the Gen 2 species. So if we were about to need that, we can call that as params, this symbol, and then you can see that it says species, but with a typo, species. So we can change that and then write species and enter to autocomplete, because I'm lazy. And if you run this, you see that we have Gen 2. So now we have this parameter ready to be used in all the document. We don't need this here. I will delete that, but be my guest, change it in all the document. I'll do that now. Here I have Gen 2. I'll change it for params, sign species. I'll have it also here, params, species, and I think also we have it here on the title. So here we can use some tricks, R tricks. If we use this backslash R, and any object of R is going to be run and executed, and we'll have our species name here. And we can do the same in this other part. So we are ready. We'll need to HTML that is quick clear, because we don't have much time. And I'll show you the result. So here we have the same thing we had before with the Gentoo species, the table, and the plots. Now we want to do the same for another species. So what we want to do now is change it for another. So what were the names of the species of the penguins? I think one was
Daily.
Adélie, yeah,
Sí.
and knit again. And we have now the Adelaide penguins with the plot and the other plot also that we didn't pay much attention, but for this new species. Here we have again the change, and we can now create a report for each species, only changing one word in the whole document. So that's it. I won't speak further because if I keep speaking, we'll be here until tomorrow. But with that, I end. I hope that that cherry on the top of the cake was worthy. And
Yes. Yeah. Thank you so much for being here. You have all the materials to the workshop. What you are going to find in the webpage is exactly the same but we going through today. Perhaps there
but
is some
better.
more activities. Yeah, yeah, explaining. I think we write in English better than we speak, but there is, and you have also our contacts, so you can write us, and we'll be try to answer if we can.